So forces in equilibrium, when we are talking about equilibrium, it simply means that the net force is equals to zero. Now, net force equals to zero doesn't mean that object is at rest. Net force can be zero when object is at rest. Then we call it as static equilibrium. And when the object is moving at constant velocity, neither changing the speed, neither the direction, that is constant velocity. In that case, we call it as kinetic equilibrium or dynamic equilibrium, one and the same thing. So in both the cases, the force is zero. Now, the most important part is like inclined problem. We have tried inclined problem on the friction part. So let us say there is a block of mass m residing on an inclined plane whose angle is theta. The mass of the block is m, and this mass object is at rest. Rest means it is not moving, right? Now, if I want to draw the free body diagram of this, can you give it a try? So, if I want to draw, it will be mg. I know that this will be my vertically downward will be mg, and this angle will be theta, right? Because if this is my 90-degree, this will be 90 minus theta. This is again 90, so this will be theta. So whatever is this angle, always remember this. And the side along the theta will be your mg cos theta. We have discussed this earlier as well. So mg sin theta will be acting downward. Now, as it is not moving, definitely there will be a friction which is acting in the opposite direction above the along the above plane, and a normal force is perpendicular to the surface. So as we know that it is at rest, okay, so it is given that the object is at rest. So I can simply say that the F net is zero. Now when say F net, it means the summation of Fy is zero and summation of Fx is also equals to zero. Now if I want to make a summation of Fy equals to zero, it simply means that the normal force has to be equals to the mg cos theta. And for summation of fx means along the plane, this direction, if I want this to be zero, then I can simply say that my friction is equals to mg sine theta. Also, from the friction, we know that what is friction? Nu times Fn, and Fn is already mg cos theta. So I can say that my friction is nu times mg cos theta. So if I plug this equation in the fx, nu mg cos theta is equals to mg sine theta. So you can say that m and mg got cancelled out. So nu will be equals to sine theta over cosine theta, which is nu equals to tan theta. So this is your coefficient of friction. If you already know the angle, you can find out the coefficient of friction if the object is at rest. So you can see that as theta increases, the coefficient of static friction also increases. This is coefficient of static friction because it is at rest. So in this question, a crane hook is in equilibrium. It is given it is in equilibrium, and three forces are shown in the diagram: T1, T2, and an upward force of 3.8 kilo. This is small k means 10 raised to power 3 Newton. Okay. You have to find out T1 and T2 if the angles are given to you. Give it a try. Be quick. Okay, pay attention. The first step, if I want to solve for equilibrium problem, the first step is to draw the free body diagram. So I take a dot, and I know it is given in the question as 3.8 into 10 raised to power 3 Newton, or you can name it as F as you wish. This is given me as tension T1. This is given me as tension T2. And the angles are also mention. So I will use the same angles. This is 60 degree and this is 30 degree. So once I have drawn this, I have to resolve this into horizontal and vertical. So this force is already in vertical direction. So I can simply write down this as 3.8 into 10 raised to power 3. Now, remember the resolution of vector. If this is T1, this is 30. What would be this component? T1 cosine 30, and here it will be T1 sine 30. Similarly, for T2, it will be T2 sine 60, and it will be downward T2 cos 60. So this is my resolved into horizontal and vertical. And then I know that if it is in at rest, or you can say at equilibrium, when it is at equilibrium, I know that the summation of fx is 0 and the summation of fy is also 0. So if I want to make equation for fx first, so fx is simply t1 sine 30 is equals to t2 sine 60. So this is my equation 1. Similarly, for fy, if I make vertical equation, which is 3.8 into 10 raised to power 3 is equals to t1 cos 30 plus t2 cos 60, right? This is my equation 2. Now physics is this much only. Now what they are asking us to find out t1 and t2. So we have two equations, two variables, t1 and t2. So from equation 1, I can substitute the value of t1 in equation 2. How? T1 can be written as T2 sine 60 divided by sine 30. So I will plug it here and I will find out T2 first. So T1, this T1 can be written as this, which is T2 sine 60 divided by sine 30 times cos 30 plus T2 cos 60. Now this whole equation is in terms of T2. T2 can be factorized and taken outside. You can solve the remaining part, sine 60 times cos 30 divided by sine 30 plus cos 60. This whole you can calculate 3.8 into 10 raised to power 3. Can you tell me how much is this by? Make sure your calculator is in degrees, guys. Sine 60 times cos 30 divided by sine 30. This is 1.5 plus cos 60. Cos 60 is 0.5. So which is 2t2 equals to 3.8 into 10 raised to power 3. So t2 will be 3.8 divided by 2 is 1.9 into 10 raised to power 3 Newton. So this is my answer for T2. Now once I got T2, you can plug it in any of the equation, either first or the second, to find out. So I will find out T1 using this equation. So T1 is 1.9 into 10 raised to power 3 into sine 60 divided by sine 30. So 1.9 into sine 60 divided by sine 30. So I will get T. Have you understood what I did here? So once you got T2, you can plug this value in this equation to find out T1. Once you solve this, you will get 3.29 into 10 raised to power 3 Newton. So these will be your answer. So you can say 1900 Newton and 3300 Newton are the value of T1 and T2. So this is a past year IB question. Give it a try. So if you look at the A part is simply asking you the magnitude of the resultant force on the balloon when it is attached to the ground. So when it is attached to the ground, the ropes are there. So you can simply say that the resultant force is nothing but 0, as the balloon is not moving. No need to mention the reason, it is just asking you the state. So 0 because the upward force, the net upward force by the two rope, that is your tension, is equals to the weight of the balloon. That's it. Or the vertically upward force is equals to the tension plus weight. So it is not moving, the balloon is not moving means the resultant force is 0. Now the most important part is the B one. Try to solve for B. So the step one, I'm drawing the free body diagram on the balloon itself. So I assume that this angle is right. This is 40 degree. Let us say that this is T2, and let us say this as T1. This is also 40. So if I want to draw the resolving, so this will be T2 cos 40 plus T1 cos 40, and upward will be 2150 Newton, because it is 2.1 into 10 raised to power 3 upward. So on the right hand side, it will be T1 sine 40. This is just the resolution of vectors we already discussed. If you have any doubt, check the description. And this will be T2 sine 40. So I know that it has been tied, so fixed rope, it is not moving. So I can simply say that T1 sine 40, that is summation of fx, is 0. T1 sine 40 is equals to T2 sine 40. So this will get cancelled out. So I will get T1 is equals to T2. So both the tension in the rope are the same. So I can simply say that summation of Fy is 0. It means that the upward force, which is 2150, is 2 times of tension into cos 40, because T1 and T2 are the same. So I assume the same tension T. So T will be, or you can say 2150 divided by 2 cos 40, dividing cos 2 cos 40 on both the side, you will get your tension. So tension will be simply, sorry, we haven't considered the weight also now. It will be the weight of the balloon as well, mg plus mg, my bad. So this will be, what is mg? Force m is given 1.95. So mg will be 1.95 into 100 into 9.8. This is 1911, right? So you can say 2150 minus 1911 is equals to 2t cos 40. So 2150 minus 1911 is 239 divided by, which is equals to 2t cos 40, right? So 239 divided by 2 cos 40 on both the side will give you t, divided by 2 divided by cos 40. So you will get 155.99. 155.99. So roughly you can say 156 Newton. That's your answer. This is for 3 mark question from IB. I hope you guys have understood. If you have any doubt, you can comment below. Okay, these are the next two part of the question. Give it a try. Be quick. C and D. C is saying the fixed ropes are released. It means that I release the ropes now. Okay. And the balloon accelerate upward. Calculate the magnitude of this initial acceleration. Just as soon as you release the ropes, the balloon will try to move up. It will accelerate up. What is that initial acceleration? So as the ropes are released, tension will be equals to 0. So calculate the magnitude of this initial. So I will use F net is equals to driving force minus resistive force. F net is mass into acceleration. Driving force is upward, which is already we know 2150. Resistive force is the weight. Weight we already calculated 1911. And mass is 1950. Mass is given to you as 1.95 into 10 raised to power 2, which is basically 195 kg. So solve this, you will get your answer simple. So 2150 minus 1911 divided by 195. 1.22 meter per second square. That's your answer, simple. Okay, so in the D part, the question is asking the balloon reaches a terminal speed 10 seconds after the takeoff. I hope you know the meaning of terminal speed. It means the net force becomes zero. The upward force F still remain constant. Describe how the magnitude of air friction on the balloon varies during the first 10 seconds of its flight. So we know that as soon as the ropes have been tied off, the balloon is moving upward. As it is moving upward, the air resistance will act in the downward direction. And after 10 seconds, you can say as the balloon is accelerating upward, its velocity increases. With increase in velocity, the air resistance acting downward also increases. As a result, after 10 seconds, the weight plus air resistance will be equals to the upward force acting on the balloon. As a result, the net force becomes zero, acceleration becomes zero, and it achieves a terminal speed. Is this part clear?
Yeah.
So you just have to write down in your own words. The meaning should be the same. So I have mentioned the keywords according to the marking scheme. If you can understand this for D. So the statement that air friction increases with increasing speed should be seen or implied. In 10-second, friction goes from 0 Newton. Friction means air resistance. From 0 to 237 Newton. Force increases from 0 until it equals to the net upward force accelerating. Okay. So anyway, however you write, if the meaning out correct out to be the same, you will get 2 marks. So this is total 8-mark question was asked in IB.